Hey everyone, thank you so much for joining us today. We're going to have this session today on SageMaker JumpStart. My name is João Moura. I'm an AI ML specialist SA. I've been very focused in the last few months in the low-code offerings that AWS has to offer within SageMaker. And so JumpStart is what we're going to be taking a look at today. We're going to have a quick overview of actually, what is the value behind it, what it provides, and then we're going to go into some pretty neat demos with natural language processing mostly of how you can actually use it in practice. And I'm going to take you through the AWS console to do this. So what is SageMaker JumpStart? JumpStart is meant to help you easily and really quickly bring machine learning applications to market. So it's a Kickstarter for machine learning use cases and applications. There are a couple really relevant aspects to SageMaker JumpStart, some different facets to this feature. First, it allows you to accelerate the time to fine-tune and deploy over 300 proven, reliable, and latest open source models. And these include ML models and algorithms from popular model zoos like the PyTorch Hub or TensorFlow Hub that were pre-trained on open source datasets, which you can one-click deploy or fine-tune on JumpStart without really having to get into all the weeds of machine learning framework and writing your own training or inference scripts. You can also get started with just a few clicks and easily bring full ML applications to market using what is called within JumpStart pre-built solutions. So these solutions can be used either out of the box as they come, or they can be customized to solve a specific business problem. And they eliminate the need to do the whole thing yourself, training the ML model, and apart from that, stringing together different components of an ML application, because the model within an ML application, the model is a component, but many other components need to be strung together to actually achieve a solution for an end-to-end use case. These solutions are pre-configured with all the necessary AWS services required to launch this use case into production, including a CloudFormation template, which gets deployed as you deploy the solution, and a reference architecture so that you properly understand what you're deploying. Beyond these two things, you can find several example notebooks and blog posts and reference videos on how to use different SageMaker features to solve ML problems directly on the JumpStart landing page, which just makes discovering this content a whole lot easier. So a quick view of the algorithms and the pre-trained models that are available on SageMaker JumpStart. They span across these three different problem types: vision, text, and tabular problems, tabular dataset-based problems, I should say. Starting from the top, in vision, there are models like YOLO, Faster RCNN. For those of you with experience in computer vision, these are state-of-the-art models for computer vision tasks, and other pre-trained models, and they address tasks like image classification, object detection, etc. In the natural language processing domain, there are pre-trained models for, again, many tasks under the umbrella of both text classification and text generation. So that means, tasks like sentence classification or question answering, which normally fall under text classification, but then also summarization, translation, which fall under the umbrella of text generation. And all of the BERT family models like BERT, Roberta, DistilBERT for faster inference, and then these generation models like GPT-2, for example. Finally, for the tabular use cases, there are a bunch of very interesting models, actually, very known ones, popular ones like GBM, CatBoost, XGBoost. These are the bread and butter of tabular datasets for classification and regression objectives. But then very recently, we added these two, I would say models, but one of them isn't really a model, AutoGluon and Tab Transformer. So Tab Transform, both are a product of Amazon Science and Amazon Engineering. AutoGluon is a low-code library that is super powerful in ensembling and joining the predictions of different models to create a very, very accurate prediction. And in fact, AutoGluon has finished top 5 in many data science competitions just with default parameters, which is astounding. And Tap Transformer is a model that came out directly out of research from Amazon, and it's the popular transformer model. It's, in a nutshell, it's the usage of the popular transformer model on classification and regression tasks with tabular data. So you might want to take a look at both of them. They're very performant and both available on JumpStart as well. So easy to train, easy to deploy. Regarding the pre-built solutions we mentioned, these are some of the available ones, not all of them, but they span, as you can see, the JumpStart team has been creating them with the vision of industry verticals or technological verticals. And so they're distributed. Let's say these solutions that have been created up to this point are distributed in these overarching use cases or domains. So there are solutions for predictive maintenance. There are solutions for financial settings like credit risk prediction or fraud detection. There are solutions for personalized recommendations like purchase modeling or entity resolution for advertising. And then there are also solutions for text analysis and natural language processing. And that's actually one of the ones we're going to be showcasing today. Things as document understanding, getting better benefit from large documents and large bodies of text, optical character recognition in handwriting, and so on. So a quick tour of the UI and what it allows you to do, and we'll take a better deep dive at this once we actually get into the AWS console. As I mentioned previously, you can easily deploy and fine-tune your models through the UI or through the JumpStart API, as we'll see, with a single click, just making sure that your data has the right format. You can then really easily manage your assets from the console itself, and this is an experience that's infused within the SageMaker Studio UI. And then you'll get pre-populated notebooks as you fine-tune or as you deploy your models on JumpStart. You won't really have to understand how to then string together the different SageMaker SDK calls to actually use those models. You'll get pre-populated notebooks to run inference on sample input that you can then customize for your own inference. With solutions, you get a similar, with the pre-built solutions, you get a similar UI where you can launch now, instead of a model training or instead of a model deployment, a full solution deployment with a single click. You can also manage them easily on the sidebar to view if they've been launched, if you want to delete all the resources, or to take a peek into these pre-populated notebooks. And again, these pre-populated notebooks that come with solutions are a lot richer. And in many cases with these solutions, they are part of the solution itself. So some part of the solution gets deployed as infrastructure as code through CloudFormation, and then the rest gets run by the user, him or herself, via notebooks. As I mentioned, you don't have to go the UI way. So the JumpStart UI is very helpful, but if you want to infuse JumpStart capabilities into your programmatic workflows, you can also take advantage of the JumpStart API, which is a recent launch. And we'll take a better look into the inner functionality of the JumpStart API, but you can train and again, deploy these pre-trained or fine-tuned models on your own data sets. These over 300 models that exist in the JumpStart catalog at this point, and infuse them into MLOps pipelines, into whatever programmatic workflow you are dealing with. For your awareness, this is the full table of the tasks that are currently supported in JumpStart. So the types of problems that are supported in JumpStart. If you can just deploy a model for inference without even fine-tuning anything, all of them you can at this point. And also which tasks can be fine-tuned on your own data currently or cannot. And the JumpStart team is working actively to support all of them, and they'll be phased out quarter by quarter. They'll be prioritized, and you'll be able to fine-tune on more and more tasks as JumpStart is more and more developed. So you can see which ones of these you can actually update the models and fine-tune them on your own data, as I said. Which frameworks are supported as well. In this case, as you'll see, the framework really gets abstracted away, because since you're not writing ML framework code yourself, it just it loses relevance what framework the model is written in and the training code is written in. And then for each one of these different use cases, the JumpStart team has published a sample notebook so that you can kickstart using that capability within JumpStart. And like I said, fine-tune or deploy one of these models. So now we're going to skip over to the AWS console, where we're going to go into SageMaker and actually get a glimpse of the hands-on example themselves. Okay, so for our hands-on example, we're going to be leveraging, for starters, we're going to be leveraging this workshop that was recently published and updated, AWS Machine Learning Low-Code Immersion Day, which is located within AWS Workshop Studio, which I'll quickly show you. You can find many different workshops for many different domains in the AWS Workshop Studio, not just ML, basically everything under the sun AWS, you'll be able to find here, and you'll also be able to follow them independently, which is great. So you don't need a solutions architect to self-enable, which is a great news in this case. And so we're going to be leveraging this this immersion day. We call them immersion days. Immersion days are basically full day or half day workshops that we lead with customers to go deep into a topic. And so for your awareness, this immersion day covers not only JumpStart, but also SageMaker Data Wrangler, which is a low-code tool to pre-process your data and do feature engineering on your data. And also SageMaker Autopilot, which allows you to automatically train a series of different models and achieve the best performing model on your tabular data. So we won't get into these two services today, but just so you know that they're available in this workshop, and you can go over that content independently or watch the webinars that cover these other two services. All right, so there's a couple of different sections to this workshop. Initially, we had two industry-focused labs or workshops, one for healthcare and life sciences, one for financial services. You can take a look at those if those interest your particular use case and they make sense in your particular use case. In this case, we're going to go into the cross-industry section, which is just a generic display of the capabilities and features of these services. And we're going to go into the JumpStart section and the natural language processing use case. So for a little bit of context, what we're going to be doing is a task called Paraphrase Classification. And so what that means is to try to classify a pair of sentences as meaning the same thing or meaning different things, also called semantic similarity. So that's a little bit more of a posh term for it. Semantic means the meaning of the sentence itself. And so what we're trying to understand is if the meaning of the two sentences, even though they might be written in different ways, if the meaning is the same, right? And we're doing this because in this context, this is important for almost any business on the planet, because nearly every business maintains contact with their customers in the form of customer support. And so you really don't want to, every single question that comes in, even if they're similar, that you'll have to redirect to a customer support representative to actually pay attention and be able to support your customers. And so the objective with this task, even though it sounds simple at first, is to give the power to a business and to a support, let's say support team, to relate different questions to pre-built and pre-thought frequently asked questions, or FAQs as they're commonly called. So this is going to enable a business to do is to map whatever FAQ they've created to questions that will obviously not come in the same format, because users just will type the question slightly differently, or even with just slightly different writing in their own style, whatever that might be. And so for this, what we're going to do is we're going to use JumpStart to fine-tune a sentence pair classification model. And so that's very broad. It's a model that can classify whatever pair of sentences into classes that it sees in the training data. And we're going to use that for paraphrase classification. So as in any ML use case or any ML problem, we have to start with data. We have to start with a data set that gets as close as possible to our problem, to representing the distribution of our problem, or even better, if we have custom data that really represents real life data that we're going to encounter when we're using the model out there in the real world. In this case, we're going to use an open source dataset called the Semantic Text Similarity dataset, or STS, which contains pairs of sentences that are extracted from various sources, various online sources, but also generated using machine translation. And they're human annotations, which in this case come in the form of a score in the range of 0 to 5, being that 0 corresponds to two sentences just having nothing to do with each other in terms of meaning, and 5 corresponding to them being completely equivalent, albeit written in a different way. And so we don't want this. We don't want a score from 0 to 5. What we want is a true or false. Is this sentence a paraphrase of the other or not? But that's a step that we'll take care of when we run our notebooks. So the flow, what we're going to do, like I said, is to gather this data set and transform it into the format that JumpStart needs for the model and for the training script to recognize the format of the data set. Then we're going to use JumpStart to fine-tune and deploy this model based on BERT. We're going to see what model we pick. And then we're going to use that fine-tuned model in a little sample frequently asked question list to, from a user question, from a simulated user question, pick out which one of our FAQs relates to that. So which one of our documented questions relates to the question that the user asked. All right, so that's that. We're gonna go into the AWS console, into the SageMaker landing page, and you can, if you don't know where to find the SageMaker landing page, you can write on the topmost search bar SageMaker, and it will pop up right here as a service. And we'll go into the Studio left panel, and we're going to launch our SageMaker Studio profile. So this webinar, the JumpStart demo user, we're going to launch Studio, and this webinar assumes some familiarity with Studio. If not, there are other resources to get enabled on Studio. But in a nutshell, Studio is the all-in-one integrated development environment for end-to-end ML development on SageMaker. So it's very similar to what you would see in a Jupyter Lab, for example, just with a lot more goodies and a lot more features that are very useful for machine learning engineers and data scientists. All right, so now we're in Studio, and what we're going to do is we're going to grab, first of all, our code from the workshop. And so we're going to scroll down a little bit in the workshop. There's going to be a code cell, which we'll copy. We'll go back to Studio. So now in the Studio landing page, we're going to open up a new terminal so we can git clone all the code files that we need in all the notebooks. And we can do that by going to the top bar, clicking File, then New, and then Terminal. We have a new terminal on Studio. Let me check what directory I'm in. All right, and we're in our root SageMaker user directory, and we're just going to paste in the commands to get our to download the whole code and notebooks, and they're right here on the LCNC folder. I'm going to go into my own, which has a little bit, which is already pre-populated, and you'll see that within LCNC you have an NLP folder, and within that NLP folder, we'll start with, well, okay. Within that NLP folder, we'll start with the prepared data notebook. So we'll open that. Okay, so every single model in JumpStart, and specifically for each task requires or expects the training script that runs in the background when you launch a training job, expects your data to be in a specific format, and that's all the work that a JumpStart user actually needs to do in code to launch a training job, is to model or to format, shape the data into an expected format. So in this case, we'll see that the expected format is, well, we'll see it in a little bit, but the expected format for sentence pair classification is a common CSV file, a simple CSV file with 3 columns, where the first column should be the label, so 0 or 1, as a binary classification, let's say, whatever category that might be. This could be a paraphrase, or this could be anything else that you were trying to classify between 2 pairs of sentences. And then each sentence in no specific order, just each sentence that you're trying to classify into paraphrase or not paraphrase. And so that's what we're going to be doing. We're just going to be first installing, upgrading the SageMaker SDK and downloading the datasets library, which is a library created by Hugging Face, and it makes it really easy to download datasets, already kind of pre-processed datasets, not necessarily in the format that we require them, but already pretty neat and pretty treated. And we're going to pull that. What matters is that we're going to pull that STS dataset that we just mentioned, so the Semantic Textual Similarity dataset. We're going to pull it from this library because it's available in that library. So first, we'll run this cell to set up permissions in our default SageMaker role, which is the IAM role that gets used by default for all calls to the SageMaker SDK. We'll run that. We'll get our SageMaker role, the ARN, our default bucket, and the region we're currently operating in, which is US East 1. And now we're going to load our STS dataset from the datasets library. So we're going to load it. It's partitioned in English because there are other languages. And we're going to get the whole data, all the partitions, train, validation, and test data. And we're going to take a quick peek at what our data looks like as well with df.head. And so right now you can see that we have headers in this dataset, sentence 1, sentence 2. And then we have the last column called similarity score. If you remember, I said that 0 corresponds to no relation whatsoever between sentences, and 5 corresponds to the exact same meaning between sentences. So in this case, looking at the first example, a plane is taking off and an airplane is taking off is the exact same sentence. You just added an obvious thing. A plane is an airplane. And then a man is playing a large flute. A man is playing a flute. Well, that's already, you know, a little bit less similar, but that's the human annotation that we have. And in the datasets documentation on this libraries page, so the dataset libraries page, you can see some examples of what the scores mean in terms of explanation. So, for example, a 3 might be that the 2 sentences are roughly equivalent, but some important information might be missing or might differ. And so in this case, since we don't want to confuse our model and we want to have the examples be as polar as they can be, what we're going to do is that we're going to threshold this data. So we're just going to say, okay, the ones that are a little bit more ambiguous and that are in this middle region between maybe 2 and 4, we'll just cut those off and keep the rest of the examples. And so that's exactly what we're going to do next with these operations in this cell. We're going to keep, as you can see, anything that is over 4 and anything that is under 2 in similarity score. And we're also going to count how many positive examples we have and how many negative. So how many examples under 2 and how many examples over 4, which are the positive, respectively the negative and the positive. And we have not too imbalanced, so we have a third less positive examples than negative, but that's not too bad at all. And so this is the dataset partition we're going to keep, and we're going to save to S3 so we can use in JumpStart training. We also created this column called labels, in which we transformed. So you can see that the left column is the index and the right column is the actual values of the labels object. And all we did was, well, if the similarity score is over 4, then we're going to create a label with value 1. If not, the label will be 0. And that's exactly what we need for our data set to be prepared to be used with JumpStart. All right, so all we have to do now is to transform the data set into the expected format, the format that I explained previously. Again, first row label 0 or 1, not a Boolean, an integer 0 or 1. And then the first sentence and then the second sentence, saved with no index and no header. So this is precisely what we're going to do. This isn't limited, an aside, just a note. This isn't limited to binary classification. You could just add more integer class labels. In this case, it's binary classification, but you can add 0, 1, 2, 3, and you would be able to classify sentence pairs into more than positive or more than true or false. So we're using zeros and ones to create a, let's say, a mocked binary classification, because those are the only two classes existent that the model will know how to classify. But you could have more categories and train your model on more labels. All right, so now these next two operations, the only thing that they do is to drop the similarity score column, which we don't need, and order the rest of the columns the way we want them. So label first, and then the two sentences. Then we're going to create a new directory and save this this data frame to a file, a CSV file. And it's going to be right here on the left on the file explorer. You can see data.csv. This is what it's going to look like. So labels, two sentences. That's our training data. And now we're going to upload our data to S3 so we can then use it in our JumpStart code. So we need the source of the data to be S3 to train our model on JumpStart. So we're going to save the data under this prefix, datasets STS paraphrase, so we don't lose it. And very importantly, we're going to print the URL of where that dataset was uploaded to on S3, and we're going to copy this because we're going to use it shortly. All right, right here. All right, great. So now we can let go of this notebook. I'm going to save these changes, and we can go into JumpStart actually. So JumpStart can be accessed in two ways. You can either go back to the launcher, the initial page, and you'll see that this card, this SageMaker JumpStart card, and you could click go to SageMaker JumpStart, or you can go to the leftmost toolbar and click this little pyramid looking, gene looking icon, and it's going to launch SageMaker JumpStart for you. So the way SageMaker JumpStart is organized is the following. You can see the landing page. So you'll have any featured content that is new or that that we want to give the opportunity for the user to discover. Then we'll have pre-built solutions right after that you could, like I said, deploy with one click. And then we'll have models, all of the available models by their domains, vision models, text models, tabular models, and how many there are. Also, you can see there are way over 300 at this point. The way that I like to navigate choosing a model, though, the best is with problem types. So with problem types, you can, instead of addressing all the models within Vision, you can say, okay, I want to solve text classification, click that and see all the available models that you can deploy or fine tune for that task. So like we said, in this case, we want sentence pair classification, and we'll click on that. Before, the last thing right here, if you would like to guide yourself by that, is what framework. So searching models by framework, and then at the very end you have like I said, all of the resources that are linked on JumpStart, like example notebooks, blog posts, and video tutorials. All right, so we'll click sentence pair classification. These are all the available models for sentence pair classification. We call these little squares model cards. And you'll have the name of the model, the task for which it's used for, and also what data set it was pre-trained in, because of course all of these models have been pre-trained on something. They're not randomly initialized. If they are fine-tunable on your own data or not, and what hub they came from. So, and this ranges from TensorFlow Hub, from the Hugging Face Model Hub. Some of them also come from the PyTorch Hub, and some from MXNet Hub. All right, so in this case, we're gonna pick a model, and we're gonna go for, let's see here, we're gonna go for Distill Roberta base, for example, which is a variant model of BERT with a little different pre-training scheme called Roberta, and then it's distilled. That's why the distill prefix is there, which means that it's gonna be smaller, so it's gonna fine-tune faster, and it's gonna do faster inference because it has less parameters, less space in disk and in GPU memory and in RAM, and it's just faster. So this is the model card. Once you click the model, the Distill Roberta base, this is what you'll get. You can either directly deploy the model with whatever configurations you want. So you can pop up this drop down, and you'll be able to select, okay, if I want to deploy this model as is, that does a task that relates to the data set that was used to pre-train it, and we'll see the details on this at the bottom of the model page. You can pick which instance you would like to deploy this model to, if you want to give a custom name to your endpoint or custom resource tags, and also if you want to, where do you want to output this this model artifact? Where do you want to put it? And then within security settings, and this will be something that you'll see repeated across the different ways you can use JumpStart. You'll see that you can either use a default IAM role that SageMaker assigns, which is the same one we saw in our prepare data notebook, right? The SageMaker default role, or you can assign a specific role that you would like, so that this deployed model only has the exact permissions that you defined. Apart from that, you can also connect this model to a virtual private cloud, to a VPC, or you can also in a more detailed way specify the encryption keys used to secure the data. So to secure this model artifact, the parameters of this model artifact at rest on S3 using KMS. And so that's direct deployment. That's not what we're going to be doing today, because we actually want to fine tune our model. Again, important to stress, you don't need to fine tune your model. If you find a model that has been pre-trained on a data set that is very similar to the use case that you are working on, and you, for example, want to check how that model will perform on your data, or actually you just want to use a model straight off the shelf, you can just deploy that model, or you can fine tune it with this dropdown. We'll go a little bit below on the model page so we can check something out before we come back to this training model interface. So at the bottom of the model page, you get all of the required details to understand what this model is, what it currently does in its pre-training form, and how you can fine tune it and how you can structure your data. And this is actually where I took the reference from to know in which format my data should be, right? So in this case, the pre-training model is just a model that was trained on text embedding first. And then it was the model that is available for deployment, that's what it says here, is created by fine-tuning the model on binary classification on this QNLI dataset, where it doesn't matter for our use case right now, but this dataset comprises of pairs of sentences. The first sentence is a question, second sentence is a context paragraph, so it's like a question answering. Sorry, it's an entailment task. So it's the pre-trained model is trained to predict if the context paragraph contains the answer to the question. That's not what we're going to use though. So we're going to skip this use the deployed model for inference part, which you could take a look into if that was your use case and that was the way you're going to use this model. What we want is fine-tuning the model on a new data set, and these are exactly the instructions that you saw in the beginning notebook. How should we structure our input, and what is the output going to be? And it's going to be this a trained model that we can easily deploy, and what is also the structure of the data that we should create. Very important to notice that this trained model that we're going to get as output is going to be very easy to deploy it through JumpStart, but it's yours to take. So as soon as you train your model, the model artifact is in a transparent way on S3, and you can grab it and deploy it elsewhere if you like. So the parameters are not secret or kept from you. The parameters of the model that you train are yours to take. All right, so we're going to now train the model. So there's a bunch of different configurations that we can include in this functionality to one-click train the model. First of all, we'll input where our data set is, right? With the data set that we just uploaded to S3. So we're going to enter an S3 bucket location, and this is precisely why we copied the location of our data set in the initial notebook. So I'm going to paste it here. We can decide again in what type of compute we want to use to train this model. And it's a good idea since these NLP models are a bit chunkier and take a while to train. They're generally trained with hardware acceleration, namely GPUs, that is very common. So we could choose a GPU accelerated instance like the ML P32X large instance, which has access to a pretty powerful GPU. Then, very helpfully, what we can do is that we can control some of the hyperparameters that this model will use for training. And this is a great plus for JumpStart. So you won't have to write the training script yourself, but some of the hyperparameters that do influence the training procedure, you will be able to change those. So things like how many epochs do you want to train, what will be the learning rate for training, the batch size, and also two recent ones, where you can choose if you want to reinitialize the top layer of the network, so the very final layer, and also if you only want to train the top layer. So if you want to freeze the big bulk of for example, the BERT model, and only train the classification layer, so the output layer where that's going to learn what label it should impute, it should assign to each data example, right? And after that, we have the same security settings. So what IAM role you would like to assign, if you want to connect it to a VPC, and if you want to encrypt as well, if you want to use your own encryption keys. And so as soon as you click train, this job is going to take off. Let me change its name because I've pre-cooked my own example. We're going to click train here. And this is what it's going to look like, preparing to train your model. And then in a little bit, training will be ready to start, and we'll start our training. So this is what we're going to see until the model is trained. It's going to be in progress, and we'll keep already some form of lineage to what happened with this training job, because we'll have everything on record, like what instance was this trained on, and what were the hyperparameters used, which is already some form of keeping track of this of training experiments. So I'm going to go into a training job that was pre-made by me, so I would have it ready because this takes some minutes. It's the exact same training job with the exact same data set and model. And you can see that now this one is complete. This one was done 2 days ago by me, so it's complete. It's the same thing. And from here, from the complete training kind of interface, this is where you'll be able to deploy now your fine-tuned model. Or in the case that you get more data in the same use case, in the same line of, so let's imagine you fine-tune your model the first time, then you were able to obtain even more data to better fine-tune your model, to improve its accuracy and its performance on your use case. You won't have to start from scratch, train it on the new data and the old data. You can, on JumpStart, incrementally train your model, which means to grab the model that is related to this model card, right, to this training job, to the first training job, grab the already fine-tuned model artifacts, and stick some more data to that model, and train it, fine tune it even further, right? And so this just helps you produce even more accurate models with smaller data sets, with incremental pieces of data sets. And so to deploy this model now, all we have to do is to, like I said, choose an instance, choose extra configurations and deploy it. Click deploy. It will take a few minutes as well. I have previously deployed this model, so I'm going to show you the already deployed model card and what that looks like. If you remember, I said that we could manage our JumpStart assets on this left toolbar. You can see that I can have visibility over the training job that is in progress and what task it's on, also what pre-training data set, the source, the framework source, but also we will have visibility onto solutions and model endpoints. And so if I go into model endpoints, here is the endpoint that I deployed after first training the distilled Roberta model. Here it is. So the endpoint status is now in service, so it's up and running, and that literally means that we have an instance that is handled and managed by SageMaker. That's what we call an endpoint instance that is ready to go for any real-time requests that I want to throw at it. And I deployed this instance to a C5x large instance, which has no GPU, but is meant for compute-heavy tasks, let's say C5. We also get where our model artifact landed and ended up, so we can pick this up right here in this URL and take it wherever we want. So now we could open the pre-populated notebook from Studio, since it's going to have data that doesn't really interest us. This will be good, so this will work with the model that we deployed. But we'll go into our file system and we'll open up the make predictions notebook, so we can check out how to make predictions on the model that we just deployed. So the data science kernel is fine for this notebook. It's just asking what environment I want to use for launching this notebook, and that's fine. And so now we're going to just run inference on the endpoint that we've created. I'm going to run this first cell, get some tooling to be able to properly visualize what the model is going to give back to us. And the question that we're going to pose is, where can I change my contact information? So this is the simulated user question, right? And our list of FAQs, which would then be mapped to some response, which I just don't have here because it's over what we're trying to prove with the model, right? Are these five, sorry. So how can I change my contact details, which is the one that we're trying to actually identify as a paraphrase? How can I change my contact details, and where can I change my contact information? A human can tell it's the exact same thing. And now we hope that the model will as well. And then the rest are clear duds that just don't have anything to do with the model. Can I change my subscription status? How should I handle missing deliveries? What is the return policy? So this is kind of, questions that many businesses might share. It's not anything specific to any industry. Maybe, retail or something that involves deliveries, but really very, very common questions. So I'm going to run this as well, create this list of FAQs. And this is the format in which we're going to send our data to the model. So each list that we're going to send to the model, each pair, is going to have both the question and the FAQ, and the model is going to just say true or false, are these paraphrases or not. All right, so we're going to now query the endpoint. This is the name of our endpoint. If the name of your endpoint is something different, just change it here as you run this notebook. And we're going to create a few helper functions to query the endpoint. You can see that we're using the Bodo3 client, Python client, and we're using the invoke endpoint method, just passing it our endpoint name, and then passing it the body as the text that we want to pass it. So it's kind of JSON encoded text that we're going to be passing it. And then a little helper function to parse the response that we get from the model, and another one to compute the probability that the model is assigning to each class, because the model returns raw logits, as they're called, and we want to turn those logits into probabilities so that we can just kind of understand how sure the model is in terms of assigned probability to yes, that is a paraphrase, or no, that's not a paraphrase. All right, then we'll just loop over every pair of FAQ question that we have. We're going to query the endpoint, and then we're gonna make the prediction and print it out. So let's start. And it was actually very quickly, you can see that this is actually making the request to the endpoint. And I'll quickly show you that on the SageMaker homepage, if you go to inference on the left toolbar and endpoints, it's right here. So you can check that the model is up and running, the status when it was created, last updated, etc. So this is our up and running endpoint. And now when we click this, since it's a lightweight model, you can see that it takes a little bit, it chugs along the inferences, but it's rather quick. And you can see that the prediction for pair 0, as we expected, is that it's a matching question. So the predicted label is 1, and then I just translated that into a string, a happy little matching question. And so all the other ones had no relationship. And if you see the list for the model prediction, so the probability list, shows that all other sentences were assigned a 99+% probability that they had an absolute no relationship, so label 0, while this first one got a 99+% probability that this is the matching question. So these two sentences are paraphrases. And that was great. We chose, basically what we ended up doing here is that we chose a highly state-of-the-art model. So it's a distilled Roberta blah, blah, blah model, and more models will come, obviously. And that's the fastest moving landscape there is the state-of-the-art models in each different, let's say, domain of machine learning. But we were able to pick up that state-of-the-art model, only do slight, light, easy transformations on our data. And we were able to, just with a few clicks, train a complex model that would require a complex algorithm to be trained. And then just use it on our own data very, very simply and very easily. So that's really where SageMaker JumpStart shines. Having said this, we're going to quickly take a look at how we would do all of this in a programmatic type of workflow before we jump into the next example. So instead of, when I say programmatic, I mean instead of going through the whole JumpStart UI to do this, we would do the same. So we would still leverage the pre-made training scripts and the pre-trained models, but we would do it through the SageMaker SDK, right? So we're going to have a quick peek at that. And that's the third and final notebook that we have in this repository called JS or JumpStart API Fine-Tune Paraphrase. We'll open that up. And we'll quickly see, we won't need to run all of this, but we'll quickly see how we would go about doing the exact same thing we just did, but through the API. So I'm going to quickly run this cell, see if we can get to some of the important bits in this notebook. First, we select. You can also programmatically select what model you want instead of via a model card, via a model identifier. So this is all of the model identifiers available on JumpStart are saved in a public file on S3 that you can download, and that's exactly what we did here in this cell. We just did it in a nifty way where we subsample the whole 300+ models into just the ones that contain this identifier called SPC. So each model contains a small identifier that specifies what task it can be used for. And this means, in this case, it's sentence pair classification, SPC. So you might have this Roberta base, but TC, for example, task classification. I think that's the prefix. Anyhow, you'll find a link to all of the JumpStart models available, a table, and their respective identifiers. So we just created in this cell a little drop down where we could see all of the models that are available for sentence pair classification, just like we could see them via model cards on the UI. We still pick this one, right? So Hugging Face SPC, the Silver Roberta base, which is the one we used initially. Then the way we'd find to the model is the following. We only need three things to use the JumpStart API. Okay, so we need, from the SageMaker SDK tool, we need the image URIs method, which is going to get us the container that we'll use to train the model. So with all the required dependencies that are needed for this specific model that we want to train. we'll get the model URIs utility, which gets the parameters, so the file containing the parameters of the pre-trained model, and then we'll get the script URIs function or method, which will get us, depending on what model we're picking, the training script for that model. And as you can see, this is all very transparent. You'll be able to pull that in, and then you'll be able to download it. So you'll take a look at it, update it if you want, play with it, customize it, whatever. And then also the hyperparameters functionality, which is just going to give us all of the available hyperparameters that we can influence in the training procedure of this specific model, right? The model identified via a model ID and a model version, which we get with the value that came from our dropdown, the SPC de Silva base model. So just to show you, in this case, it's important to define what training instance type we want, because the container image, for example, will change. The dependencies will change according to if we're training this model on CPU or GPU. And we're going to use these three functions and get, which just via a model ID and a model version will map that model ID and version to the container that we need, the script that we need, and where is the model parameters. All right, so I just ran this so you can see what it is. I ran the cell and we'll get the ARN for a container on ECR, on Elastic Container Registry. Here it is. It's a Hugging Face PyTorch training container. And the S3 direction for this transfer learning script for SPC, sentence pair classification, and then the tar file where the model parameters, pre-trained model parameters are.
All right, so apart from that, we'll just set some training parameters, like where our data is on S3, which, if you remember, we copied from the first notebook, where we want our output to land, and then we'll get the hyperparameters that we actually have access to, and I'll show it to you. So this is the exact same thing as we saw in the UI. Epochs, learning rate of the Atom optimizer, batch size, and then the reinitialize top layer and train only top layer parameters. And then we would use SageMaker SDK abstractions to train this model. So if you're not familiar with SageMaker SDK, I won't get too into this, but the estimator component is the API that handles the whole lifecycle of training. So deploying your instance, starting the container, within that instance, training your model, and then uploading your trained model to S3. And the only thing that really matters here is that you can see we're passing in the training image URI. We're passing in the source, the training script as source directory parameter, which is our what SageMaker will use as our training script, and also model URI, which is the parameters for a pre-trained model that we want to use in our training script, as well as our hyperparameters that will get injected to the training script as it starts. And then we would just run .fit on this estimator, much similar to if some of you are familiar with sklearn estimators, right? You call .fit passing the data in, and that's that. So we're not going to run another training job because I don't need to waste GPU resources to show you the exact same thing. But this is how you would train the model, and then you would deploy the model much like we did previously. Instead of now grabbing the container that is required for training, we will get the container that has the needed dependencies for inference, which are very different. It needs a model serving framework and software, so it's a different container altogether. And in this case, in the case of like NLP models, in the case of Hugging Face models, it is a different container, in fact. And we'll get another script, which is now not the training script, but the inference script. So the script that will be used inside the endpoint to know how to respond to individual requests. And then we would just deploy our estimator with all of these, with the rest of the parameters that we set, our inference script and our inference image, and we would be able to run inference exactly in the same way we did via the UI, right? With our make predictions notebook. All right, great. So for now, this is all in the part of training and fine-tuning models yourself. What we're going to do now is take a look at one of the most popular pre-built solutions in JumpStart, which is called the document understanding solution. All right, so now I relocated to another region where I have pre-deployed this pre-built solution to have it ready to go for the webinar. So I'm now in a different region. I'll launch a fresh SageMaker Studio user, so we can understand how we would deploy and then properly use the solution. All right, it's coming up. Okay, here it is. So you can find, now we're back in the SageMaker JumpStart landing page, right? Which you can access on the, remembering, on the leftmost toolbar, this little gene-looking symbol icon. And you can find the pre-built solutions under solutions, right? Right here, exploring all solutions. There are currently 19 or 20. Not all of them are deployed in every region. That's why you see 15 here. But the one we're going to be using is, so remembering, there's all of these: fraud detection, corporate credit rating, churn prediction, a lot of helpful, useful stuff here. We're going to be taking a look at the document understanding one. And so this is going to serve as an example of what is the information that you get from a pre-built solution, and then how you can customize it and how you can deploy it and how you can easily use it. All right, so the document understanding solution, you can see that already. First thing is you can just launch it straight away with just defining what role you want the AWS infrastructure that is launched, what role you want it to assume. But you get a very thorough description of what resources this solution is actually going to deploy and how it's going to work. So in this case, the solution is geared towards the huge problem that many, if not all companies have, that there's too many textual documents and too many reports, and there's just text everywhere that humans are, human-generated text, machine-generated text, just a bunch of text everywhere, and it's not always easy or obvious how to extract information from text, right? And it wouldn't really be easy to get a very, let's say, broad array of textual analysis tools with state-of-the-art machine learning. And so that is what this document understanding solution focuses on. And so it deploys minimal resources, but most importantly, all the required notebooks and pre-populated code to deploy 4 different models for 4 different use cases, one of them fine-tuned. So what we're going to end up with is 4 different endpoints, model endpoints, one that will give us a text summarization, which we can pass whatever text, and it will get us a concise summary of that text. One for question answering. So given context, give me the span within that text that corresponds to an answer to my question. Entity recognition, so named entity recognition within this text, what is an organization, what is a person, etc. And relationship extraction, which we'll take a look at in the end. So there's a little description here for what type of summarization, how is this achieved for these models, and what does it actually do. There's a little also a little representation of the output of each one of these. So the summarization the output of the summarization model will just be generated text. The output of question answering would be the span within the context text where our answer is located, right? Also with a score, probability, and the start and end locations within that string, within that text where our answer is. For entity recognition, we'll get both entities with where they are and what are they labeled. So if it's an organization, if it's a language, if it's a person, and we'll see the full scope of what this model can identify in terms of labels and noun chunks as well. And then for relationship extraction, we'll be able to get we'll be able to get these different types of relationships. So cause-effect relationships, product producer, entity origin, a bunch of them, right? And this is how you pass input and output to them, so you can identify this a little bit better. And like I said, if you remember, so this is all going to be deployed using a CloudFormation template, but you'll also get a view of what the architecture of the solution looks like. It's a pretty simple one. So there's an Amazon S3 bucket where the model artifacts will be saved, and that will be used also as storage for data to fuel a SageMaker training job. And then we'll deploy all these 4 different models to SageMaker endpoints, and we'll monitor both training jobs and our endpoints on Amazon CloudWatch, which is automatic as well. And you can then see logs for your training job, logs for your endpoint, metrics for your endpoint, like GPU usage, CPU usage, and a bunch of things. All right, so as you click launch on this solution, what is going to happen is that it's going to take only a couple minutes to deploy minimal infrastructure, like in US, the fresh S3 bucket, and a couple other things. You could go to the CloudFormation console, for example, and check the deployment of this the solution, and I'll show it to you. You can also check it on the assets bar on the left on JumpStart, so you can see solutions. I have the document understanding solution ready to go here, and if I click it, this is the page that you would see once the pre-built solution will be deployed, right? So you could open you can open a sample notebook that will take you to the very first notebook that you need to run to complete kind of the deployment of the solution, and then all of the generated artifacts up to this point, which get in a very useful way, get like associated with this page. So as you deploy new models, which I've previously done, they'll go under this little table. They'll be recognized under this table, and you can then shut them down if you want right from here. And also you can delete the whole thing. You can just delete all of the resources that this pre-built solution deployed with one click in one button. Delete all resources. All right, so just to check, we're in CloudFormation now, and you can see that there's a stack that's been deployed here. That is the SageMaker document understanding stack, right? So this is all deployed via CloudFormation. You can go in here, you could check what resources were output and what outputs, what events happened. It doesn't really matter to us at this point. And we'll just check what is happening in the notebooks, all right? So we can see how this was done and how you could customize it. More importantly, how you could also customize it for your own use case or for changing a model or whatever. So launching the document understanding solution also creates a directory, a new directory in your file system that gives you this, right? A bunch of different things that are used and that you can use to deploy the rest of these, the things that are not automatic, right? Because you need to plug in certain things. And we'll go into the notebooks folder. And here they are, the 4 notebooks for the 4 different use cases: summarization, question answering, entity recognition, relationship extraction. We'll start with the first one, summarization. And this is going to use the transformers library, which is created by Hugging Face as well. So you might be familiar with it. It's a very popular library that uses transformer models. Used to be just for NLP use cases. Now it's grown to be for computer vision and even reinforcement learning. So definitely check it out if you haven't. And all we're going to do is that we're going to download a configuration file the configuration that came from the launch of our CloudFormation stack. So we'll run this little cell, and we have it in all the config in a little object called configuration. And let me see if I can grab it. No, I can't, but it's no problem. And I've pre-deployed this model, as I told you, the way you would do it. Obviously, you would run this. It would only take a couple of minutes since we're now not really training a model, and all of the code is already included within the directory that the pre-built solution launch built for you, right? Everything is here. Within containers, you'll be able to find all of the required code for the 4 use cases. And this is precisely where you can influence the solution. We'll get to that in another minute. But in this case, everything is pre-populated for you. The location of the training script for summarization is included already. All of the needed configurations are included. And so you would only need this SageMaker functionality PyTorch model, this part of the SageMaker SDK, which you would then deploy to whatever instance type you wanted to. I deployed this model to a GPU-backed instance also, so that we can have it kind of chug along faster, because it's a big model. And so if we can quickly explore the file system on what we got from this, if we go into, not only did we get the notebook that we could just not even run cell by cell, we could run the whole thing as run all cells, and it would just work out of the box. But we also get, if we go into summarization, we get the requirements that are used, the requirements file that is used to install the needed libraries to deploy this model, which is just transformers in the SageMaker SDK. And you will also get the inference script, which is of high value in this case, because this is where you can really influence. You can pick up from something that works and add on whatever you want. You could limit the parameters that the model could get. You can see, in this case, the model that is being grabbed is a T5 model, which is a really popular generation model, but you can just switch this out for another. And especially with this transformers library, the way the model would do inference would just be the same, because the models have the same classes they inherit from. And so you could switch this out. You can add more pre-processing in the input function. You could add, different parameters or different ways to predict in the predict function. And these functions are the ones that run every time. Just for some context on SageMaker, these functions are the functions that run every time the endpoint gets a request. So predict function, all of these input function, predict function, and output function are called in sequence once the endpoint gets an inference request. And whatever is in here is what will run in the prediction function. So you can alter this and then deploy your altered script starting from an already working basis. So let's see what happens, right? We now have our model deployed. Actually, we can even take a look at this here. This is the new region I switched into, North California, maybe, I think so. And you can see that I have 4 endpoints deployed. I'll show you all other 3 of them, but one for relationship extraction, one for entity recognition, one for question answering, one for summarization. And now we're targeting the summarization endpoint. So we have this beefy article here that is about Amazon TextTract, which is a text analysis service that we have that does OCR, recognizes handwritten digits, recognizes tables, forms, etc. And it's a lot, right? You can see that it's a lot of text. And what happens when we send this text? So we grab that and throw it into a dictionary, saying text with the key as text and the value as the text that we just wrote. And then to this predictor object that we just created, which gets created as you deploy your model. So this predictor is just a wrapper around a model endpoint. We call the .predict method on it, passing in our data. And we'll do that. You can see that it takes a while because it's the beefiest model we've deployed. And then while the star is there, that means that it's still processing and generating text for this to summarize this huge bit of text. Now we can print it, and you see that we have kind of this little neat executive summary for our text. So Amazon TextTract is a machine learning service, blah blah blah, that extracts printed text and other data from documents as well as tables and forms. Very fluent, as you can see. That's one of the characteristics of these generation models. They're really fluent, even though they might not understand the domain or the technical domain very well. They're actually very fluent. And so, taking into consideration that this model was not fine-tuned on any data that really that really relates to our specific use case, it's just a model that we caught off the shelf, and now we're using to the best of its abilities to summarize a kind of technical text. And it didn't go bad at all. If this was, if it had a lot of domain-specific language, for example, it would be prudent to check that the performance of this model wouldn't be very degraded because of the distribution shift in data, right? It learned on, news data, for example, and then suddenly you're sending it highly technologically with language with a lot of technological jargon, for example, right? You then be able to clean up both of these, the endpoint, so stop the endpoint, because remember, the endpoint that is up and running, you're paying for 24/7, right? Until you delete it. You can delete the endpoint and its configuration, just like this. And so this is, again, another state-of-the-art model, deployed very easily. We're going to see that we're going to deploy the other three. I'll quickly show you the example and train one of them, actually fine-tune one of them with a lot of ease. And this is for this specific use case of document understanding, where you still run some of the notebooks to define what model which one of these four models you actually want to deploy, if not all of them. But many of the other solutions deploy, a lot more resources. Some of them, some visualization resources, whatever is needed to address the whole use case, right? So the whole of document understanding on these, at least these four facets that we're analyzing. All right, so this is going to be, the examples are going to be very similar, but I'm just going to show you question answering and entity recognition as well, because I think it's pretty interesting to see the functioning of these models. So question answering will have a very similar flow to what we just did with summarization. We'll get the needed configuration from S3. I'll skip over this part, then we'll deploy the model now with the code pertaining to question answering, right? So this is another folder that you could change and customize as you wish, which is going to deploy a BERT large uncased model fine-tuned on Squad, which is a question answering dataset. And so I've previously deployed this model. As you can see, model.deploy. It's already been deployed. And the first example that was here was pretty simple, like what's my name? And then context is my name is Thom. And we'll get the response and we'll print it just so we can see it, or at least the shape of the response. So the model is 97, 98% sure that the answer is Tom to the question, what is my name, right? So this is the shape of the input. It's one key of the dictionary is the question, one key is the context. And then we also get the, oh no, nothing, just that, yeah, precisely. So my name is Tom. And the answer is Tom. Now, the other thing we can get, so I just attempted this because I thought it would be a little bit more interesting. I stole a little bit of the text from the summarization use case that speaks about TextRect. So it has a bunch of information, but in the middle, it says that Amazon TextRect now supports processing printed documents in these 5 languages: Spanish, German, Italian, French, Portuguese. And what I want to ask it is, given this context, what language can I send documents in? So we're going to run this. Now we're going to print the answer. And here it is. So it actually gives us 2 answers. It gives us one with 80% confidence that the answer is Spanish, German, Italian, new line, French, and Portuguese, which is awesome. It was able to capture the exact span of the question that I was asking, even though it's never seen like this text, not even similar to it probably in its training. And then a couple other kind of crappier questions. Let's say one of them with less than 10% confidence, the other one with 3% confidence. One of them, like the answer was Spanish, the other was Portuguese. So the first one, the one with the most confidence was the correct span, and that's great. So now that's 2 use cases, one for summarization, one for question answering, which we could have done in one call, right? We could just, in the same notebook, call the 2 models, and for the same passage of text, we would get all of this textual functionality. Last example, I think, yeah, exactly. Last example, I would do entity recognition because this also is interesting. I think relationship extraction is a little bit beyond the scope. It's very interesting. You can explore it in your own time, but I'll showcase this last one. Actually, I'll go to the 4th one as well. Entity recognition. In this case, so named entity recognition is the task of grabbing from text entities that fit classes, like, oh, this clearly is an organization, this clearly is a person, or this clearly is a brand, or whatever that might be. The process in the notebook is the same. So we just get the configuration, we give a name to the model, we deploy that model with a new script, which again, you can influence, you can customize. And then another one. We have basically another text analysis tool. You can see that this is this specific model was pre-trained on a data set called one notes 5, and that data set includes all of these types of labels. So it can grab people, organizations, locations, countries, products, I mean, a bunch of different things. And what we're going to pass it is Amazon SageMaker. This is the sentence that we'll pass it is Amazon SageMaker is a fully managed service that provides every developer and data scientist with the ability to build, train, deploy machine learning, blah, blah, blah. Right? So let's grab this. This is a non-interesting, in my opinion, example, because the only thing it captures is Amazon SageMaker, and it defines that as an org because it kind of looks like it, right? Since it's never seen probably this. It defines it predicts that this would be an organization, even though this might fit better as, for example, a product, right? But maybe it's only seen more real non-software products as products. But if I say, for example, Amazon SageMaker is a fully managed service created by João, by me, and then we parse out that response again, you can see that now it not only caught the organization, but it also caught my name as a person, right? Which is pretty neat. And so this is not just because it knows all the names. Obviously, this is a deep learning model. It's not because it has a list of all the possible names. It's semantic. So it pays attention to the rest of the sentence, and it's contextual, right? Created by, this most likely is a person. Created by is generally associated with people. So this is a person, right? And we get that. So that will be a third use case. The final use case, we would need to fine tune, and I did before the webinar. So in this case, we would use the SageMaker SDK with a data set that looks like this. And let me show you. It's open source as well from a conference, from a task called SemEval, Semantic Evaluation. And the data set would look something like this. So sentences, let me show you. Yeah, sentences, for example, with entities inside, and then a label naming what is the actual relationship between both. Like the author of a keygen uses a disassembler to look at the raw assembly code, and this would be an instrument, this would be an agency. This one is kind of a weird one, to be honest. But if we look at another one, let's see. Or for example, let's see here. The girl showed a photo of apple tree being the first entity, blossom on a fruit tree in the Central Valley. And so tree would be the component, blossom would be the whole, or cause and effect relationship. So a bunch of different relationships that this can pick up. So in this case, all I did was to train this model on this new data set on a GPU-backed instance. And here are some huge logs of that training run. You can see that there's a bunch of, this might be interesting to look at. There's some different stages to training a model on SageMaker. It first prepares the instance, then it downloads the input data up front, or streams it if you want to, in another input method, and then it downloads the container image, and finally it starts your training script. So this is where your training script is launched, and this is all the logs that come from the container. You can get all those logs in the notebook, right? Where the notebook that is running the container, the notebook that is running the job, even though the job is running on a remote training job, not in the compute of the notebook itself. And then finally, you would get the model. The model will be updated to S3. You see training job completed, took about 300 seconds. And this one didn't give me, it seemed like it isn't enough data. This wasn't enough data to get a proper performance from the model, because I tripped, and so I fell, passing it this, being that the first entity is tripped and fell is the other entity. And so what I was looking for was cause and effect, right? Tripped and fell, but it failed miserably. So in this case, the data set probably wasn't enough. And so, yeah, this is obviously one training. Everything can go differently because a pre-trained model supposedly has at least the capabilities for what it was pre-trained on. A fine-tuned model, well, it will depend on how much data was passed on to it, right? Before the webinar ends, don't forget to delete all of these very important. Don't forget to delete all of these endpoints and these resources. Otherwise, you'll be still paying for them. So I'm gonna run all of these final cells for all of these notebooks and delete the endpoints. Just to check, we could go back to the endpoints and see them getting deleted, all of them. So yeah, I just refreshed my page and my endpoints are all gone, which is great. No more money spent. And that's really all. So that's all we have for today. Thank you again so much for joining. I hope this showcase of SageMaker JumpStart was useful for you, and we do hope that you get hands-on and feel free to please communicate with us regarding to what you're able to build with JumpStart and any feedback on the service. It's a fast-moving service with a lot of nice features in the works. So I hope it was very useful for you, certainly. We'll share all of these resources that were linked in the slides in the slide deck. And again, thank you very much for joining, and build on.